Thank you, Vanya. So I'm going to talk about making stuff, but automated making stuff. So manufacturing, traditional manufacturing is big, heavy industry. We take raw materials out of the ground, refine them into stocks fabricated into parts with big machines, and it's all assembled. And every product has a separate tree, and we ship stuff all over the planet. And obviously, with fuel costs and global warming, this is a problem. It's a big, ugly mess. Maybe there's a way that we can do some of this stuff locally and go straight from raw materials to products with some magical technology X, we'll call it, and just mix assembly and fabrication right together. So there's a candidate for this technology X. I'm actually speaking a little too fast. It's called freeform fabrication or 3D printing or rapid prototyping. The idea is you take your envisioned product as a 3D model, CAD model, and send it to a machine, and the machine squirts out material and builds up the object layer by layer. And the commercial technology typically makes plastic or metal parts, but mechanical parts. So my research has been on taking this technology and making it capable of producing complete finished devices. So making the batteries, making the transistors, making the wiring, making the circuit board, making the motors, everything. I built 2 separate systems to do this. This is a lab system. I jokingly call this the Pro model. It was the first one I built. It's big and heavy. It's granite. 2 separate tools, each of which works with a variety of materials. One works at high temperature, one works at room temperature. And then the second system, Fab at Home, which is what I'm really here to talk about. Fab at Home takes that lab technology and just tries to give it out to the world and recruit people to help us make this technology more affordable, more powerful, so that we can all do this in our garages or in our kitchens and make products by just downloading them and printing them out right there. So both of these machines can make mechanical parts just like the commercial technologies can. A variety of materials, rubber, plastic, epoxy, all sorts of stuff, plaster and so on. Pretty much if you can push it through a syringe, you can use it. But now if you take another material like some silver powder or some aluminum powder and you mix it into these materials, you can make something like a circuit board. So in the lower left here should be a video actually, but anyway, I'll just gesticulate. What happens there is that there's actually a flexible circuit board you can just shove your components into, and it's a working circuit. It's a rapid way of prototyping the circuits. This is the tested video, by the way. You can also do batteries. In the background, if you just peek through the crack in the middle there's actually a zinc air battery being printed. It's really accelerated. Behind this, you'll see an IPMC actuator. This is an artificial muscle. It's a polymer that changes shape in response to an electrical signal. The problem here is, as an engineer, I use Windows, and this presentation's on Mac, and it didn't convert very well. So, as I was saying before, you can also do transistors and relays. So we added an inkjet head to the Fab at Home system, just a HP commodity inkjet head. It's a $70 part. And you can print transistors, you can print relays. And in collaboration with people at Cornell and biomedical engineering, we've shown that you can actually make replacement living tissues, MRI or CT scan damaged tissue, extract cells and culture them, and take that shape and reproduce it, and then reimplant it in the body, and you got replacement organs. And then on the lighter side, we can make things like toys. In this case, sit at home, invent a toy for your child. Gumby, just print out the circuit, drop in batteries, drop in LED, and you've got a toy with eyes light up when you squeeze the chest. Or a more practical application, an LED flashlight. Everything is printed here except for the LED light bulb and the batteries themselves, although we could, as I said before, print the batteries too. And there's a video here in which you see this thing growing really rapidly, and then you squeeze the button and the light goes on. And then for the fatigue party host, as I said, food is a lot of fun to play with a Fab at Home. Heat up the syringe, you can make chocolates, you can make fancy cake decorations in multiple colors, hors d'oeuvres in goat cheese and jam, and even bakeware using food-safe silicone rubber. We've actually got a lot of media attention for this project, which is exactly what we wanted. We wanted to draw attention to rapid prototyping technology and get it out to people. 11 million page downloads from our website. Science Museum in London has a copy of, or has one of the machines, and that flashlight actually. And there are over 130 Fab at Home users worldwide so far, and the number's growing all the time, even in Brazil, South Africa, Japan. And the project is fanning out into some commercialization efforts. There's one in Albuquerque, there's one in Texas, We have a partnership with SolidWorks to do educational curriculum for secondary schools. And there's some hobbyist websites that are just stealing bits of technology from us and putting them on CNC machines and so on. So my last slide was actually supposed to be discussing this donated Fab at Home machine. But I would just like to say that I'm actually from Philadelphia, or actually I consider myself Philadelphian now. I've lived here for 16 years when I wasn't in school. And so this is actually a Philadelphia project. Thank you very much.